All right, guys, we're going to go through this semester final review. I'm going to start with states of matter. I'm going to go through this fairly quickly. If you guys have questions, you can either rewatch it, you can pause it, or you can ask me about it. All right, those are your choices. So we're going to go through our first section is states of matter. The first question is classify the following as a solid, a liquid, or a gas. All right, orange juice. I hope all of you guys know that is a liquid. Okay, that's my O. Helium in a balloon. Helium is a gas. Steam. Steam is water in gas form. Okay, so that's going to be a gas. Paper is a solid. Oxygen is a gas. Water is a liquid. Carbon dioxide is a gas. Gasoline, the kind that you put in your car, is a liquid. A chair is a solid. Gatorade would be a liquid. Ice is a solid. Okay, it's frozen water. Dew is a liquid. Dew is the condensation that forms on grass. So it's water vapor that comes out of the air and settles on the grass as the temperature cools. Okay, that's why we get it first thing in the morning. It forms at night. So it's a liquid. Coins are a solid. Wood is a solid, and vapor is a gas. Vapor is just another word for a gas, basically. All right, number 2. In the boxes below, draw the particle arrangement of the 3 states of matter. Now, it's been a long time since we've done this, all right, but you guys should remember that the particle arrangement in a solid is pretty uniform, and they are close together. They're closely packed. So the particle arrangement would look something like that. Okay, close together. And they vibrate a little bit. I'm going to write that on here even though it didn't say to do that. They vibrate. Okay, so they do move, but not a lot. Liquid, they start moving a little bit further apart. And they start moving a little bit more as well. So they'll move somewhat. Okay, they slide past each other. That's what makes it like a liquid. Okay, a gas, your particles are very far apart, very spread out, and you have a lot of movement, a lot of kinetic energy going on there. So you get a lot of movement with a gas. Okay, as the temperature increases, your kinetic energy increases. All right, number 3. Label the phase change diagram below. So over here we have our nice tightly packed particles, so that would make this a solid. Okay, this is a solid. As the solid begins to warm up on the x-axis here, on the y-axis we have temperature, and on the x-axis we have heat energy. Okay, so like the kinetic energy basically of the particles. So in a solid, you've got your barely moving, vibrating particles, so that are tightly packed. Excuse me. And then as the temperature increases, your solid will begin to melt. Okay, so going this way as we're going up, we get melting. Okay, I'll address the other direction in just a second. Once it begins to melt, think about ice. Okay, so this is your solid ice, then ice melts, and it becomes water or liquid. Okay, so liquid would be the next. And again, the particles start to spread out and move around a little bit. Then as the temperature continues to increase, you're going to get evaporation. So your water now begins to turn into a water vapor or steam, okay, or a gas. So that's what this state of matter is. It's a gas. Your particles are spread out and they're moving quite a bit. Lots of kinetic energy. Okay, then as we come down, going the other way, as the gas starts to form back into a liquid, we call that condensation. Okay, becomes a liquid, and then as the liquid turns into a solid, we would say that it is freezing. All right, so you guys are definitely going to need to know what is happening on this plateau, what is happening at this plateau, and that you start as a solid, you melt, you go into a liquid, you evaporate, you go into a gas. All right. In the phase change diagram, where will the substance change from a solid to a liquid? That would be point B. What do we call the point where the solid changes from a solid to a liquid? We call that melting point. In the phase change diagram, where will a substance change from a liquid to a gas? So that would be this section right here, D, where we have evaporation. Number 7, what do we call the point where a liquid changes to a gas? Evaporation. What do we call the point where a gas changes to a liquid? So coming back down, we call that condensation. Okay, so just remember, these two happen at the same place. It just depends on whether or not you're heating something up or cooling it down as to the term that you use. Number 9, what do we call the point where a liquid changes to a solid? So if you're going from a liquid to a solid, we would call that freezing, the freezing point. And number 10, in what state are the particles furthest apart and have the most energy? That would be up here when it's a gas. And in what state are the particles closest together and have the least kinetic energy? That would be a solid. Okay, if you guys have more questions about this, just let me know.